this video lecture, I will discuss about axioms of probability and addition rule on the events. After that, we discuss very simple examples to understand the algebra of events. So let us go with what are the basic axioms of probability. So axioms are basically the assumptions which are very fundamental in nature, those not required any proof. So first axiom is non-negativity. That means probability of any event E is either positive or zero. This implies probability cannot be negative. Second axiom says certainty. That means probability of total sample space as, here it is taken as omega. So you can take S, both are common notations in the literature. So probability of total sample space is 1. Third axiom is very important. It states that for any two disjoint, or you can say mutually exclusive events, A and B, mutually exclusive means if A will happen, B will not happen. That means A intersection B equal to phi. So this means P of A intersection B is equal to P of phi, and probability of phi is 0. So if events are mutually exclusive, then probability of getting A union B, or I can say probability of getting at least one, is equal to probability of A plus probability of B. This is called additivity in case of mutually exclusive events. If events are not mutually exclusive, then we have one more term that we will discuss in coming slides, which is called addition rule of probability. So let us see one example here. So the example states that six-sided die is rolled twice. That means single die is rolled 2 times. So what is the probability that sum of dice is either 7 or 11? So you clearly see what is sample space. It consists of 36. That is 6 outcomes on first die into 6 outcomes on second dice equal to 36 outcomes are in total. And if you write the sample space, you have a structure of outcomes which total are here. You can check out. These are the favorable cases for sum to be 7. So 1 comma 6, you can increase the first order pair and decrease the second one. So 2 comma 5, 3 comma 4, 4 comma 3, and 5 comma 2, and 6 comma 1. So these are total 6 outcomes. So this means the probability that P of sum equal to 7 is 6 by 36. Favorable are 6, total are 36 outcomes. Similarly, the probability that sum is 11. So these two are favorable outcomes when sum is 11. So this implies P of sum equal to 11 is 2 by 36. Because these two events are mutually exclusive, that means if sum is 7, sum cannot be 11 for the same numbers. That means there are no two numbers whose sum is 7 as well as 11. So by using the third axiom, we can write probability of at least A or B, or you can say P of A or B is equal to P of A plus P of B, which is probability of this 6 by 36 plus this one is 2 by 36. So 1 by 6 plus 1 by 18 equal to 8 by 36, which is 4 by 18 or 2 by 9. So final one is 2 by 9. Now let us see set operations and algebra of events. So this is very important in notation form and in language also. What is the meaning of A union B in case of A and B are events? So it is called happening of A or B. So A union B implies A or B. You can say probability, or simply this is used when the term like at least one, that is A or B or both. Similarly, this A intersection B is commonly used when word use and. So probability of getting A and B, or simply you can write A intersection B is A and B. So this is also sometimes called A and B both. Probability of happening both means A intersection B. And A complement, you already know, it says A does not occur. A does not happen. And A minus B, A but not B. So this is sometimes called A minus B, or sometimes called A intersection B bar. That means A but not B. So this is used as A but not B. So these are some common uh, phrases when used frequently in the scenario-based problems. So you can easily identify the phrases in the problem. Let us see the addition rule. As I said, when events are not mutually exclusive, then the rule says addition rule. And what is the rule here? Probability of happening P of at least one. One is P of A plus P of B minus P of both. So this is the rule here. And complementary of event you already know. This implies from here P of A plus probability of A complement is 1. So that means probability of happening of A plus probability of non-happening of A. Total probability is 1 now. So this addition rule is particularly very important. So when two or three things are given, you can find easily what is the at least one, or if it is given, then you can find probability of both happening. So let us see one example here. So a bag contains 4 green, 6 black, and 7 white balls. A ball is drawn at random. What is the probability that ball drawn is either green or black? So you can see here which operations would apply. So the notation or phrase is here or. So that means you have to find out the probability of that is either green ball or black ball. So you can define two events, A as green ball, B as black ball. So you have the information that the total sample I have is here in the bag. This is your bag. This art is not good. It looks not as a bag. Let us make it bag. So if I have a certain kind of structure, let's say it's a bag here. So in this there are 6 green balls, 7 black balls, and 7 white balls, not 7 blacks are 6 here. 6 black balls. So by looking this, we have total or no, this is 4. Again, I'm doing mistake here. So let's correct it. So 4 balls. 4 green, 6 black, 7 white. So 4 plus 6, 10, and then total I have now 17. So what is the probability of A? A means green ball. So it is also very clear that green cannot be black, cannot be white. Similarly, black cannot be green, cannot be white. So all three balls, or you can say, or the events A, B, these are mutually exclusive. So probability of A means green balls. So total favorable or 4 balls and total balls are 17. Similarly, probability of B will be black ball. There are 6 black balls, so 6 by 17. What you have to find out? Find out P of A union B, because the word or is used. So we have to write P of A plus P of B minus P of A intersection B. But now here, the intersection here is 0, because A and B are mutually exclusive. That means if ball is green, it cannot be black. And this implies here A intersection B equal to 5, and this implies P of A intersection B is equal to P of 5, which is 0. So by this, I can write this P of A not intersection union probability of A plus probability of B. That means I have now 4 by 17 and plus 6 by 17. So is equal to 10 by 17. This is probability of drawing a green ball or black ball. Similarly, you can see the solution is here. Now look at the next problem here, which I want to display here, this one. So read the complete problem. The probability that a student will solve problem A is 2 by 3. So probability that students solve problem A equal to 2 by 3. This is given. Second statement says the probability that he means student will not solve problem B is 5 by 9. So given that probability of not solved problem B, that means B complement is equal to 5 by 9, and from here I can write probability of B, that means he will solve problem B is 1 minus probability of B C, and which is 1 minus 5 by 9, so it is 9 minus 5, 4 by 9. Third statement says if the probability that students solve at least one, so note here the phrase at least one problem is 4 by 5. This means this is given, and third information given is P of A union B is equal to 4 by 9. What you have to find? What is the probability that student means he will solve both problems? So that means you have to find out probability of A intersection B. So it's very easy one. Probability of A given, probability of here B you obtain, and probability of A union B. So this you can write by addition rule as probability of A plus probability of B minus probability of A union B. So this means 2 by 3 plus 4 by 9 minus 4 by 9. Answer is 2 by 3. So this is the directly based on addition rule. Okay, here the mistake. This value given is 4 by 5 here. So let's correct it. 4 by 5 here. So it is 4 by 5 here. And then this answer will be changed. And the correct answer is 14 by 45. So its correct answer is 14 by 45. Similarly, you can solve this particular problem. So here, probability of the computer software company is building for computer program A and B. The probability of getting software A is 3 by 5. The probability of getting software B is 1 by 3. And the probability of getting both is 1 by 8. So you have to find what is the probability that company will get at least one software. So given informations are probability of getting software A. So P of A is 3 by 5. Then P of B is 1 by 3 and P of A both means intersection. So B is equal to 1 by 8. You have to find out P of A union B. So this can be obtained directly by using addition rule. So this I leave for you as an exercise. You can find out. Now here I will explain one more problem and it has three parts. So problem states that you have 100 students appears for two examinations. There are two examinations. 60 students passed the first exam, 50 students pass the second exam, 30 students pass both exam. So that means let's A be the event that student pass in exam 1. B is the event that student pass in exam 2. So from here, what is given to you? Probability of A is 60 by 100 because total 100 students are given. So 60 pass exam 1, 60 by 100 and probability of B will be exam 2 how many passed? 50 by 100 and both exam how many pass? Probability of A intersection B is equal to 30 by 100. What you have to find? So find here, first one is probability of A union B. Second one, B part is probability that student pass exactly one exam. So this you have to find out exactly. So P of exactly A or B. That means not both. So exactly either A or B, not both. So let us understand this. And the third one is C part is failed in both exams. So P of student failed in both exam. So this is as per the addition rule. These two are the new. So let us explain them how to find exactly A or B. So you have you can check out the Venn diagram here. So I have this event A and this event B. This is the event A, this is event B. So what is this common region? This is event A intersection B. Now this says probability of exactly A or B. Exactly one. That means either A or B, not both. So exactly one means either I have A or B. So what I should write? I simply write let's P of A, and then I don't want this common portion. Okay, so I will write P of A plus P of B. So this says either A or B. I don't want both. So I will write here P of A intersection B. Now this you think that is the addition rule. Yeah. But here you note down when I'm considering probability of A, this region, probability of A, this region coming first time. When I'm taking probability of B, this region again coming. So it is repeating while counting these two, it is appears two times. So I don't want any number of times, so I will subtract here two times. So this formula become now P of A plus P of B minus 2 times P of A intersection B. This is the formula for exactly one exam. And the last one is this one, failed in both exam means P of A intersection B means passed in both. So if I apply complement on this, so this is called failed in both, and this one is 1 minus P of A union B. That means total probability and pass in either A or B or both. So with this understanding, you have now the solution here. So n stands for the how many number. So there are total 100. So this can divide by 100. I written the probability. They are writing the number of. Okay. So this is the final one for addition rule. And then I have here this exactly one. So A minus B or B minus A. So this is written as, you can check out this. Exactly one means this P of A plus P of B minus P of A intersection B and minus P of intersection B. So this and this becomes two times what I wrote earlier. So answer is 0.5. And the third one is probability of failed in both exam. And this means failing both means neither pass in A nor pass in this. That means 1 minus A union B. So A union B we obtain where in previously first part we obtained this as 0.8. So I subtracted here and I got 0.2. So I hope this is very clear. So if, yeah, okay, fine. Now you can try one more problem, and this is the sixth one. Yeah, this is fifth example here. Now here you can check out the sixth one. and it is again based on the addition rule. A computer software company is bidding. Okay, this is the same problem as I completed. So this is how you can find out or apply the basic axioms on the probability. And let us summarize it. So in summary, what I got, first point is you have three axioms. The first one is probability of any event is zero or positive. Second axiom is probability of entire sample space equal to 1. And third is when events are mutually exclusive, then simultaneous probability. That means this at least one is sum of individual. So P of A plus P of B. And this rule can be extended up to any number of events A, B, C, D. So in that case, A union B union C union D will be P of A plus P of B plus P of C plus P of D. Okay. So the condition only is if A intersection B is equal to phi, meaning is events are mutually exclusive. That means if A will happen, B will not happen. On B will happen, A will not happen. Second rule we have done as addition rule, which says this whether events are mutually exclusive or whether not mutually exclusive, you can apply the rule here P of A union B equal to P of A and plus P of B minus P of A intersection B. So when this is given, this is given, and this is given, you can find out this. Or if this is given, this one given, this one given, you can find out the. So probability of A or B, or at least you can find out this. Probability of finding simultaneous or both, you can find out by using the last column, last one, last term. And third rule is A but not B. So third rule is P of A intersection B bar. What does it mean? You can check out here. I have this event as A, this event as B. So what is common in that? Common here is this region A intersection B. So now look at what I want to find. A should happen, but B should not happen. So if I write this as P of A, so when writing P of A, I am considering this common portion also. But I don't want any portion of B because this is A but not B. So I will subtract minus P of A intersection B. Similarly, P of A, you can write the another one, probability of A bar and B. This means probability of B but not A. This will simply probability of B minus probability of A intersection B. Because I want B but not A, so I will take entire B, and when I will take entire B here, I will consider this common portion, this one. So I have taken this and I subtracted it, so I will get only B but not A. So these two rules are very easy by Venn diagram. So this is about the axioms of probability and addition rule, and then algebra of events. I hope you understand this.